What's up, guys? Welcome back to Fantastic Chemistry Podcast. Tuzgi and I are the hosts of this podcast, and we're on the last episode of this podcast. Finally, yay! It's been a long time for you listening with us, but we really appreciate your loyalty. You've been listening with us. You've been sticking with us for at the very first episode to the last episode. We really appreciate you. But don't forget, if you like our podcast, don't forget to click like, subscribe, or vote 5-star, and leave a comment if you would like to. So we're gonna make our podcast go viral. All right, last episode. So chapter 15, the nuclear chemistry. So before we get into the detail, let's talk about the sponsor who makes this podcast possible. We're going to talk about Kraft and Heinz Company, right? Commonly known as Kraft Heinz. I'm sure you have seen them many places every time when you go to the grocery store. Kraft Heinz Company is an American food company by a merger between Kraft and Heinz. Come from these two people. H.J. Heinz, we talked about him in the last episode. We also have James Lewis Kraft, these two are founding fathers of these two companies separately, not together. Okay, combined Kraft and Heinz. So the Kraft Heinz Company are the third largest food company in North America and the fifth largest food company in the world. I'll take a look here. So Pepsi is number one. Always Pepsi. Number two is Tyson Foods. So those who I'm sure you're familiar with that. Like with every time when you buy meat, those are Tyson's. Nestle, so cereals, coffee creamer, chocolate, some kind of snack. Those are from Nestle. Okay, and Kraft Heinz number 5. We got Coca-Cola is number 8. Okay, I'm sure you're familiar with at least some of these. Their products are really popular. We have Planters, that all the nuts, cheese, Philadelphia. We got Kool-Aid, mac and cheese. We love, most of us love mac and cheese. Capri Sun is like, we grew up with Capri Sun. Golden Circle. Golden Circle is, what is that? Like a fruit juice. I think it's juice. Yeah, I think juice. And tomato ketchup. Yeah, Heinz. Okay. We have Lunchable. Some of you stick with Lunchable. Jello, Velveeta cheese. We have a lot. I'm sure you're familiar with all of this. All right. And the mergers happened in 2015, but that does not affect the right to Heinz Field for the home of Pittsburgh Steelers. Okay, yeah, we talked about last time. So Heinz purchased that in 2001. 2015, they merged, Heinz and Kraft merged, but this Heinz Field is still Heinz Field. All right, so the last episode, so we talk about nuclear chemistry. We're gonna talk about like all the how it works, the application about it. Let's start with the difference between the nuclear chemistry to a regular chemistry. Okay. Now, a regular chemical reaction, if you take a look right here. So, the reaction occurs at a valence shell. We talk about all valence electron, like exchange valence electron, right? And the reactant are converted to new compounds. So whatever, start with calcium carbonate, you get different compound. Iron oxide, you get rust. Totally different compound, different properties. Okay. All other factors, the external factors like concentration, pressure, temperature, catalyst, all these affect the rate of the reaction. And the energy that comes out or released or absorbed is somewhere between negative 200 to 200 kilojoule. So it could be small. 200 kilojoule is pretty big. All right. Now, nuclear reactions. What's the difference then? Well, the reaction does not happen on a valence shell. It happens in a nucleus. No electron sharing. Electron is like no. The nuclear reaction occurs at a very high temperature, and that high temperature, electron is not there anymore. Electron got ionized, or everything become ion. Just the nucleus. Right? We talk about nucleus only. The product is different, a new element, not a new compound. Right? But it's become a new element. Start with uranium, go to krypton and barium. We have 2 deuterium. We got tritium and hydrogen gas, hydrogen atoms. Okay, these are atoms. Okay, produce and absorb tremendously high amount of energy. Let's take a look. In a regular reaction, the energy involved about negative 200 up to plus 200 kilojoule per mole. But in a nuclear reaction, 10 to the 13, 10 to the 11, that's really, really high, extremely high. And all external factors does not affect the rate of the nuclear reaction, has nothing to do with it. Okay. All right. Before we get into the detail, let's talk about something that we need to review. So the first thing is atomic symbol. Now let's talk about this on the next video. Okay.